You are welcome to online lectures with Farmington the Schoolboy. Today we look at physics, and the topic is scalar and vector quantities. As usual, we'll pick a question from the topic and solve. And our question source for today is 1978 JAM question 1, as stated in Prep 50 Physics UTME past questions. The question is taken from page 6, question 1. Page 6, question 1. Let me write it on the board. Okay. The question says, a man walks 1 kilometer due east and then 1 kilometer due north. His displacement is A, 1 kilometer north 15 degrees east, B, 2 kilometer root 2 kilometer north 45 degrees east, C, 1 kilometer north 30 degrees east, D, root 2 kilometer north 60 degrees east. All right, this question wants us to find the displacement of the man that started from one point, started moving due east, and got to a point and diverted and started moving north due north. So they wanted to check the displacement of the man from where he started to where he stopped. You know, displacement is a vector quantity, while the counterpart, distance, is what? Scalar quantity. In terms of magnitude, even in magnitude, they are not exactly the same, because displacement, let's assume if you want to check displacement of somebody Or let me draw this to it. Let me sketch the vector diagram of this and use it to explain what I want to explain. Let's go. Solution. The man started from here. Let's assume the man started from here. This is at any point we'll put a cardinal point there. At this point, let's assume the man started here because he moved due north. The man started somewhere here. So I'll put a cardinal point here. At this point, cardinal point. Here is north, here is south, here is east, here is what? West. So this is where the man started from. I can call it anything, point A or anything I want to call it. This is where the man started from. They say the man moved due east in east direction, 1 kilometer, something like this, and stop here. Let's call here 1 kilometer. So I'll stop at this point. We'll put another point here. Here is still north. Here is still west. Here is west. Here is east. And here is south. So it's moved from here to here, 1 kilometer. The person say the man moved again, the same 1 kilometer due north. The same size, the same 1 kilometer due north. Something stop at somewhere here. This is another point. This is another 1 kilometer. We put another point here. This is still north. This is east. This is south, and this is west. So the man moved from here. This is a right angle triangle. The man moved from here and stopped here, and moved due north and stopped here. This is the man's present location. He started from here. So let me now explain what I wanted to explain that time. I didn't even get asked to find the man's distance covered. Distance covered is actually this 1 kilometer plus 1 kilometer is simply 2 kilometers. But the displacement is different. The magnitude of the displacement is not 1 plus 2, 1 plus 1, 2. No. The magnitude of the displacement is actually the shortest means route from the man's origin to the man's new location. The shortest, and that shortest route is this. This is actually the man's magnitude. This is the magnitude of the man's displacement. Let me call it x. This is the magnitude of his displacement. You know, displacement is a vector quantity, so it will have magnitude and what? Direction. This is the magnitude of the man's displacement. But the man's distance is actually 1 kilometer plus 1 kilometer, which is 2 kilometers. But the magnitude of the man's displacement is the shortest route from where he started. This to here is the man's displacement. So it's x. I call it x. Because we are told to find displacement x, finding this x is not enough. You must find the what? Direction too. So this is the magnitude of the man's what? Displacement. Now to find the direction parts, this angle here, I can call it anything. I can call it angle alpha, no problem. This angle alpha that lies between the north pole and this angle alpha demands that it be between the north pole and the mass magnitude of what? The displacement gives you the mass bearing. Gives the bearing. So if you now want to actually state the mass displacement, it must include the mass magnitude of what? The displacement and the direction. It will appear like this. The mass displacement will now become x, which is what? The magnitude of this what? Displacement. You can call it x kilometer. It should be x kilometer. Then north, because the mass is lie between north and east, northeast. The mass position is northeast direction. So not this alpha here, not this one here. There's another angle here. We can call it theta. Not this angle, but this alpha. North alpha degree what? East. This is how the man's displacement will appear. So let us now find the one after the other. Let's find this x and find this alpha and take it off from there. So now let's go. Let's find x from this diagram. This x, this here is a angle, this is a right angle triangle. So to find this, and this is the longest side, hypotenuse side. This is the opposite side, and this is the adjacent. So you can find this x using Pythagoras theorem. We are using Pythagoras theorem. X square is equal to what? 1 square plus what? All in kilometer. So let me not bother myself putting kilometer. After I put it at the end, 1 square. So s square is now equal to 1 square is 1. 1 square is 1, which is what? 2. So x is actually what? Root 2 what? Kilometer. We have found x to be what? Root 2 kilometer. So now let's find this alpha. Before we can find this alpha, we need to find this theta. And from this right angle triangle now, remember our SOHCAHTOA. SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent to hypotenuse. Tangent is equal to opposite over what? Adjacent. Now, this is opposite to this angle, so this is opposite, and this is adjacent. So this is one. So opposite is 1 kilometer. Adjacent one. We can also use this, but let's just use this one, so we don't waste our time. 1 kilometer, opposite, adjacent. So opposite over adjacent is tan theta. So tan theta is equal to what? 1 kilometer over what? 1 kilometer, which is what? 1. So theta is now equal to what? Tan inverse of 1. And tan inverse of 1 is what? 45 degrees Celsius. Tan inverse of 1 is 45 degrees Celsius. That means tan 45 is what? 1. That means tan 45 is what? 1. So theta is actually what? 45 degrees Celsius. Let's go back to the diagram. Here to here is angle 90. What it means is that theta plus alpha is equal to what? 90 degrees. From the diagram, that means alpha is equal to what? 90 degrees minus what? Minus what? Theta. This implies that alpha is equal to what? 90 degrees. The theta we got is what? 45 degrees, which is now equal to what? 45 degrees. So alpha is 45 degrees, theta is what? 45 degrees. So we have found our alpha to be what? 45 degrees. So let us now substitute from this here now. Let's substitute the value of x and value of alpha. That will give us the displacement of the man. So that means the man displacement is now equal to what? X is root 2. So we have root 2 kilometer north. Alpha is 45 degrees, not 45 degrees east. This is the man's displacement. It has the magnitude part and the direction part. The man's direction is not 45 degrees east is the man's direction. But the magnitude of that displacement is what? X, which is root 2 kilometer. So let's look at the options. Option 1 says 1 kilometer north, 15 degrees east. I will not take this. B says root 2 kilometer north, 45 degrees east. This is what I got, so I will take this. But let me take other options. C says 1 kilometer north, 30 degrees east. I will not take this. D says root 2 kilometer north, 60 degrees east. I will not take this. The correct answer is B, which is root 2 kilometer north, 45 degrees east. Root 2 kilometer north, 45 degrees east. This question is physics 1978, yes. JAMB physics 1978. Question what? Question 1. Question 1, Q1, question 1. So the answer to JAMB physics, let's say with 8 question 1 is B, root 2 kilometers north, 45 degrees east. I'll give 2 minutes for reactions. If there's anything you did not understand, look at the board clearly. If there's anything you don't understand while I was solving this, please feel free to ask. If there's any step you did not understand, please ask question. Call the number on the screen, on the board, 081-3868-2003. Or as you watch this lecture, you can also drop your question in the live chat. I will attend to you. I am looking through the live chat now. You can drop your question on there. I will attend to you. So we have 2 minutes to do that. We have 2 minutes to do that. Ask your question if you have any. Drop your question on the chat group, on the chat. Ask your question. Drop your question on the chat. We have 1 minute to go. Okay, while we wait for questions, I have an announcement to make. One or two announcements anyway. Every Saturday, 7 a.m. to 7:10 a.m., I organize academic competition I titled Academic Battle with From a Time to the School Boy. It's an online competition that features one subject per Saturday. And the subject for the coming Saturday, which is 9 December 2023, is pharmacology. The title of that competition is Pharmacology Battle 2.0 with From a Time to the School Boy. There are prizes to be won, and the registration is free of charge. If you are interested, chat me up on this line on the board, 081-3868-2003, and I'll send you the link for registration and other information you need to get for the information. Second announcement is that every day I am live every day here. Every morning 3 a.m. I am live here solving pharmaceutical calculation question. 3:30 a.m. I switch over to chemistry. 4 a.m. I switch over to physics. Then 4:30 is mathematics every morning. Please avail yourself of this opportunity. Share this information with your friends, with your colleagues, with your children, with your students. Someone that needs this lecture may be out there. Also, please subscribe to my YouTube channel. My YouTube channel name is From Eternity the Schoolboy. Please, and click on the bell-like notification button so that whenever I go live, you will follow suit. You'll be notified. And God bless you as you do so. See you next time. Remember, 4:30 a.m. I will be back here for mathematics. See you there.